The acute inflammatory response, which begins immediately after the injury, could last up to 4 days. This phase is an elaborate cascade of both pro-inflammatory and anti-inflammatory mediators, and the result is influenced by the balancing of the two. At the time of the injury, the bacteria have entered the wound. Pro-inflammatory mediators, bradykinins, prostaglandins, and histamine are then released, which stimulate nociceptors that detect the pain of the injury, promote vasodilation and vascular permeability at the injured area. Vasodilation leads to swelling that makes gaps in the endothelial cells, which allows proteins to exit with water into the tissues. Migration of plasma and leukocytes from blood into the tissue of the injured area show the cardinal signs of inflammation, such as heat, redness, swelling, pain, and loss of function. Cell metabolism is increased, which results in changes of cellular function and the appearance of neutrophils and other granulocytes. Neutrophils then dominate the first 6 to 24 hours after the injury. They target bacteria to destroy through the process of phagocytosis, but can damage healthy tissues in the process. Platelets and neutrophilic leukocytes then begin to tumble along the walls of the vessel, called margination. After that, through a process called pavementing, neutrophils adhere to the lining on the venule side of the endothelial lining on the venule side of the capillary junction. The start of coagulation then begins, which means there's a platelet plug formed and fibrinogen is converted to fibrin in order to produce clotting. This begins the process of angiogenesis, which is the formation of new blood vessels to repair the injured ones, and leads to the beginning of the proliferation phase.
The proliferation phase is the phase that begins to resolve the inflammation and cardinal signs of injury. This phase can last anywhere from 3 days to 3 weeks. The keratinocytes secrete protein to rebuild the membrane and restores the vascular network and granulation tissue. During this phase, it is important to be careful because the type 3 collagen fibers make the area vulnerable to re-injury. The purpose of collagen is for the wound to regain normal functions. Re-epithelialization starts the migration of cells to form new strong blood vessels through angiogenesis. The initiation of cells migrating is because of tension, which leads to an increase in permeability of the membrane. This causes the wound to form a protective layer of extracellular matrix, which deposits fibroblasts, granulocytes, macrophages, and blood vessels. Then there is an increase in fibroblasts to lay the ground substance of the membrane. After the protective layer forms, then the proteoglycans, consisting of collagen, proliferate the healthy and damaged cells to stabilize the wound. The primary intention causes minimal degradation, degrading and depositing of the collagen and extracellular matrix fill the wound and provides a platform for adhesion and granulation of tissue. Secondary intention causes a loss of tissue or complex tissue injuries, which leads to scar tissues. Because of the risk of scar tissue and re-injury, the proliferation phase is essential in the purpose of protecting, rebuilding, and restoring the vascular networking. Once the wound gap is filled and cell adhesion has occurred, the maturity of granulation tissue ends, as well as the proliferation phase.
The maturation phase is the final phase in the healing process. It lasts at least a year or more after the injury occurs. The number of macrophages, neutrophils, and fibroblasts return to the amount before the injury occurred. During this phase, type 1 collagen is produced to replace the weak type 3 collagen. This strengthens the tissue as more layers of type 1 collagen is added. The maturation phase is concerned with strengthening and fully recovering the tissue. It is considered to be in this phase until the tissue is at full recovery.